Okay, here we are. We are talking about describing distributions with numbers. This is section 1.3, our first section after our quiz. And the essential question for today is, why is it necessary to have more than one way to measure the center of a set of data? We have a few, and there are some circumstances in which one is better than another. You have to make that determination. So let's talk about one of the measures of center, mean. This is very common, used measure of center. We use it in terms of calculating grades. You add up all of your values in your data set and you divide it by the total number of values you have in that data set. This is just the mathematical equation for doing so. It's not resistant. It's sensitive to outliers. It's even sensitive to skew. It gets pulled towards the tail or towards the outliers. So in terms of measures of center, it is not always the best one to use whenever a data set is skewed or has outliers. It's always pulled towards the tail of the distribution. So in the median circumstance, it's the midpoint of a distribution. You line up your data set in your distribution and you get to the center value, and that's your median. If it has an even number of data values in your data set, then you line them up, and when you find the center two values, you take the mean of those two values, and that is your median. The median is more resistant to outliers and skew. Skew may pull your median slightly towards the skew, but much less so than the mean, and it would have to be a pretty strong skew to see any significant change in your median. So in situations where you have outliers, median is probably the best measure of center to go with. Mode is simply the value that occurs the most. It's not necessarily the center, but it is a measure of center because it tends to be at the center. However, it's just not commonly used. It's the highest peak in a distribution. So these are our measures of center. Let's talk about situations in which we would use the median or the mode and the median or the mean and compare what those situations would look like. When we have a roughly symmetric distribution, the two values are close together. So one could use one or the other, whichever would be easier to calculate. If the distribution is exactly symmetric, then the mean and the median are exactly the same value. So when you have a roughly symmetric or exactly symmetric distribution, either one would be a good measure of center. But in a skewed distribution, the mean is usually farther out towards the long tail than it's the median. So you would have to make a judgment as to which one you would use. Most likely you would use the median since it's resisting the skew more than the mean is. Okay? Let's talk about quartiles. When you divide up your data in terms of constructing a box plot, first you find the median of your data. So that's the middle number of your data set. You line up your data in order from smallest to largest and pick the middle number or the mean of the two middle numbers. And when you do so, the median is called the Q2 in terms of purposes of constructing your box plot. That means 50% of the data is below that number. Then you have divided your data set into an upper and a lower half. The median of the lower half is what we call Q1. And it's simply just finding the median of the lower half of your data. And then the upper half of your data, you can find the median of that. That's your Q3. And you simply find the median of your upper half, and that's it. These quartiles tell us where a bunch of our data is. So if I am at Q1, 25% of my data is below that. Q2, 50% of the data is below that. At Q3, 75% of the data is below that. So in between Q1 and Q3 is your middle center 50% of the data. Okay? We use these numbers to construct a box plot, but we need a few more numbers to add to that in order to finish our box plot. Box plot uses what's called a 5-number summary. Those 5 numbers, that's your minimum, Q1, Q2, also known as the median, Q3, and your maximum. With those 5 numbers, you can construct your box plot. The minimum is the end of the lower end of your smallest whisker. Then Q1 begins your box. The median is the center of your box. Q3 is the end of the box, and the maximum is the end of the whisker. With these numbers, we can also produce what's called an IQR. Now, this is going to go in your formulas section on the back of this note guide. The IQR, the interquartile range, is when you take your Q3 and subtract your Q1. This is where the middle 50% of your data lives. We need the IQR mostly because this is going to be the first time that we can find out whether or not something is an outlier in a situation. There are many ways to find out whether or not something's an outlier, but one that you're going to use in here is by taking 1.5 times your IQR and subtracting it from your lower quartile Q1. If a data value falls below that number, it's an outlier. If you take 1.5 times your IQR and add it to Q3, the quartile right above the median, if your data is above that number, it's an outlier. So this is our first test to see whether or not something is an outlier. These two go in your formulas part of your note guide. You need to know these formulas. If we want to determine whether or not the distribution has symmetry, you can look at the length of the box band or whiskers. If the whiskers are longer, that means your data is spread out longer. And if the whiskers are shorter, that means it's more condensed and consistent. So this is a way for you to judge spread and symmetry and skew even. You can also construct what's called a modified box plot. In these situations, you would need to have outliers in order to do so. You would construct your box plot as normal, except for wherever your outlier end would be, you place an asterisk. And you end the whisker instead of at that outlier point, you would end the whisker at the next highest or lowest data value, whichever end you are speaking of. Instead. We'll do an example like this sometime. So let's calculate the mean, median, and mode of a data set. First, we calculate the mean. We can add up all of our data, which is 9,200 divided by 16, and we get 575. To calculate the median, you line up your numbers in order from smallest to largest. And here I notice that we have an even number of data in our set. So I'm going to have to take the mean of the center two numbers, 570 and 610, in order to come up with 590. The mode is simply the number that occurs the most, and that number is 610. That number occurs 3 times, and no other number occurs 3 times like that. So we have a single mode data set. Now I want to draw your attention to your calculator now. Your calculator can do a whole lot of this stuff for you. So I've already entered that data set in my calculator. I entered it into list 1. And using list 1, if I hit stat, after you enter your data into list 1, hit stat, and then instead of edit, if we're editing a list, I'm going to calculate, and then I'm going to calculate one variable, statistics, and I am going to use list 1, and when I calculate, I get that the mean is 575. There down. The median is 590. So it just did 2 of those calculations for me. Okay. The main reason I'm drawing your attention to the calculator, though, is looking at our next example. We have the scores of 18 first-year college women and 20 of your first-year college men. And these are the scores on what's called the SSHA, Survey of Study Habits and Attitudes. So we're going to compare the distributions of college women to college men, and we're going to use box and whisker plots. And in order to get the data that we're going to use in those side-by-side box plots, we're going to use our calculator. So I'm going to show you how to enter that into the calculator. First, I entered into list 2 and 3. List 2 has the data for the women. List 3 has the data for the men. So I'm going to go into stat plot. And you see that I've turned on the stat plots for 1 and 2. In plot 1, it is on, and then I have selected the box and whisker plot using list 2. I also see that my second stat plot is on, and I have selected the box and whisker plot, and I have used list 3. So now I'm going to graph those two side by side. And if you did not get this nice pretty view of that, remember you always go to your zoom and arrow down to selection 9, because that's your zoom stat whenever you're doing a stat plot, zoom stat. And there are your box and whisker plots. The ends of the whiskers are your minimum and maximum. The edges of the box are your Q1 and Q3, and the middle of the box is your median. So here is another view of the side-by-side box plot. Now, computing the numerical summaries for these two distributions, I can go into the one variable statistics for each of those lists, and I can find that the mean is 141.06 for the women, and the median is 138.05. The IQR is 28. And for the men, the mean is 121.25, and the median is 114.5, with the IQR of 45. Remember, the IQR is a form of spread measure, so I see that the women have a smaller spread of their 50%, middle 50% of data than the men. That's also evidenced by the smaller box. I also see that the right half of the box and whisker for women, as well as the right half of the box and whisker for men, are longer than the left halves. That tells me that this distribution is skewed right, because in each of these sections, remember, is 25% of the data. So the bottom 50% of the data is in a much smaller range than the top 50% of the data, and that happens for both men and women. In each case, this is what's dragging the mean towards the tail. So that's why the mean in both cases is bigger or larger than the median. In the case of the men, the median is about 7, almost 7. It's 6.75 higher than the median. With the women, it's only 3.01 higher. So I'm going to say that the difference in skew is slightly stronger of a skew for the men, because the mean was dragged a little bit further. So comparing the two, I'm going to say that the women's scores have a smaller IQR than the men, so it means that the women's scores are more consistent, where the men's scores have a higher variability. The centers for the men show that the distribution is skewed right, because the mean has been pulled higher than the median. For the women, the distribution is also skewed right, but less significantly, with a mean of 141.06 and median of 138.05. overall, women have higher scores than men. Now, whether or not the higher score means what it means, I am no expert in this type of test, so I cannot tell you. Okay, so this is what you should have in order to be prepared for class tomorrow. Make sure if you would like a reference, bring your book. We have a worksheet that is not in the book, but if you would like additional information about how to construct box plots, etc., then bring your book to class tomorrow. If not, you will be fine. Have a good afternoon.